Have you ever wondered how your browser fetches a web page in just a few seconds? Behind the scenes, it's all thanks to network protocols, and two of the most important ones are HTTP and HTTPS. Let's break them down. What is HTTP? HTTP stands for Hypertext Transfer Protocol. It's a set of rules that allow web browsers and web servers to communicate. Think of it as the language your browser uses to request web pages, images, or videos from a website server. When you type a URL into your browser and hit Enter, your browser sends an HTTP request to the server. The server then responds with the requested page, usually in HTML format. This process is called a request-response model. HTTP is stateless, which means it doesn't retain any information between different requests. Each time you click a link or refresh a page, a new connection is made, completely independent of the previous one. While HTTP is fast and efficient, it has a major downside. It transmits data in plain text. That means if someone is monitoring the network, they could potentially see everything you're doing, including login details or personal information. To solve the security issue, we use HTTPS, which stands for Hypertext Transfer Protocol Secure. HTTPS uses encryption to protect the data sent between your browser and the server. This is done through protocols called SSL or TLS. More accurately, TLS, which is the modern and secure version of SSL. With HTTPS, even if someone intercepts the data, they won't be able to read it because it's encrypted. You've probably noticed the padlock icon in the browser's address bar when visiting a secure website. That's HTTPS at work. Now let's take a closer look at how this encryption actually works. It all starts with a process called the TLS handshake, which happens when you connect to a secure website. Step 1. Client hello. Your browser sends a client hello message to the server. This message contains the browser's supported TLS version, a random number, and a list of supported encryption algorithms, also called cipher suites. Step 2. Server hello. The server replies with a server hello, which includes its own random number, the chosen cipher suite, and a digital certificate. This certificate proves the identity of the server and contains its public key, signed by a trusted certificate authority, or CA. Step 3. Key exchange. The browser verifies the server's certificate. If it's valid, the browser generates a pre-master key, encrypts it with the server's public key, and sends it back. Only the server could decrypt this, using its private key. Step 4. Session key generation. Now, both the browser and the server use their random numbers and the pre-master key to generate the same session key. This session key is a symmetric key used to encrypt and decrypt all data during the session. Step 5. Secure communication begins. Both sides confirm the handshake by sending a final message. From this point onward, all communication is fully encrypted. This entire handshake happens in milliseconds and ensures that your personal data stays private and secure. Whether you're browsing the web, logging into your email, or entering payment details, understanding how HTTP and HTTPS work is essential, especially if you're preparing for IT certifications like CompTIA Network Plus or Security Plus. HTTPS isn't just a tech upgrade. It's the standard for a safer internet. Why HTTPS matters. Using HTTPS protects users from cyber threats like man-in-the-middle attacks, where attackers try to intercept or alter data. It also helps build trust. Search engines and modern browsers favor HTTPS websites, and users are more likely to interact with them. In fact, many modern browsers now block or warn users about sites that still use HTTP, especially if they involve forms, logins, or sensitive data. Key differences: HTTP versus HTTPS. Let's recap the key differences. HTTP is unencrypted, while HTTPS uses encryption through SSL or TLS. HTTPS protects data from being read or modified during transit. HTTP uses port 80 by default. HTTPS uses port 443. Modern websites are expected to use HTTPS for better security, SEO, and user trust. Want to learn more about networking protocols? Stay tuned for our next video on FTP, SMTP, and DNS. Don't forget to like and subscribe.